Okay, this is Atwood's machine, which is your first connected body problem. This should be done roughly after chapters 5 and 6. There is friction on the pulley. The tensions on the same are not quite the same. They're close. So there is an error margin here because what we tell you is the equation is not the true equation. But hey, this is the beginning when we're fudging. Okay, again, you have a worksheet at the front. So you want to take the equation for the acceleration theory, complete the free body diagram, find the acceleration of the system, and then solve for the tension, either using the big mass or the small mass equation set. And they should give you exactly the same answer. On problem number 2, you're again looking at the graph, and you're measuring the slope, which would be the reciprocal mass, and you should get 1 over 600 grams. Okay, on this slide we see a professionally done and built equipment on an Atwood's machine. On the next one, we see roughly the same apparatus that we're going to use here. Advance this after you've watched the video. Okay, again, cops caught me last time, can't do it. This is not your device. It looks more like the one on the diagram from Index to Physics demonstrations. But hey, they're a very high-priced university, and we're a community college, so we couldn't get those kinds of equipment. But we are using a photo gate. Not a little clock. We can get it accurate to 3 decimal places because we're using old equipment instead of new equipment. And the data is pretty much repeatable, but there is somewhere between a 10 to 15% error margin if you do it correctly. Please watch the video before you move along so you get the idea of what's happening. In our case, we let the smaller mass go up and the heavier mass go down, and we attach a card to the smaller mass that goes through the photogate detector. If I found one online that would do it, or if I could get a camera in there, I'd put that in here so you could see it. But like I said, the cops warned me. Okay, so here we have the base equations that you see in the handout sheet at the first slide after the introductory slide. The large mass will go down, the small mass will go up, the wheel will turn, which indicates there's actually friction there. And so the theoretical acceleration value would be gravity times the difference in the masses divided by the sum of the masses. The experimental acceleration would be 2y divided by the time measured squared. Delta y here would be the length of the card, which is at 5 centimeters. Or I should say 5 inches. That would be 12.5 centimeters. Then we talk about the instructions on how to get the card to go through, how to align your photo gate so it's just above the card. So the initial velocity is essentially 0. If the initial velocity is not essentially 0, you could get margins of over 200% error. You've got to be careful. The instructions here are for the devices used because instruction manuals get lost, instruction manuals disappear from the web, so if they're embedded in the lab manual itself, it preserves the lab forever as long as it's being used. In this case, we're shifting 5 grams from one side, the heavier mass, to the lighter mass, and so that's a difference of 10 grams each time. If we were in a lab setting and we were short on time, we'd be shifting 10 grams a piece, so we'd only have to do 5 to get the same scale. We have sample graphs and spreadsheets so that you can look and build yours properly, but this is the first time you will have raw spreadsheet data with the base data and tables on there, and it's in the Excel extracted file. Okay, here's what's going to look like for your first one, where you're holding the total mass constant. So you're shifting from the large mass to the small mass by a difference of, you're starting with a difference of 10, then 20, then 30, then 40, etc. over the 10 times. And so you're graphing the theoretical value versus the experimental value. Now, the tables are set in kilodynes because we wanted a whole number increment on both sides, and your accelerations would be in accelerations per centimeter per second squared. On the right side, you're going to see that we keep the mass difference the same for each, but we're adding 20 grams to each side. Now this makes it harder because as we do this, we're increasing friction, and friction is a much nastier problem, and you can see the air margins are much, much greater because in the first part, friction is the same, in the second part, friction is increasing. And so you can see what the graphs look like when you do that. Okay, so again, a warning about your photogate, making sure your data looks good. And here are all the instructions. Basically, you can name the cells if you want to. Without it, you'd have to refer to the exact location and make them $E, $8, $E, $9, etc. So this is your third Excel instruction, and after the fourth one, you're kind of on your own. You should know Excel well enough. It tells you how to construct the spreadsheet that I've given you, where the cells should be located, what the formula involved should be in each particular case, what the formula is. And then it tells you to go ahead, set up the graphs. The only new thing is you're now going to have to go in and construct a second graph because you've got two y-axes on the same one. And if you didn't listen to me, by the time you're doing this, you may not like your data. There is a way to fix your data. You'd have to add a third data set and expand your graph. This tells you how to do it using a gap correction. This tells you how to set up the instructions to do 2 curves instead of 1. And there's a cheat by setting it up so that you go from kilodynes over to theory, and you've got that time column. You could edit the time column if you needed that third curve. If not, you kill it and you rename your series function using the commands that you're given here. This tells you how to set that up and to rename it. This tells you how to repeat it, to remove things, to use this command in Excel. You can do this by hand if you're clever, but I decided it was too hard to do on your third attempt, so I'm telling you how to do it from the charts. Actually, you can click on the thing and edit it in Excel above on the chart data range, but if you don't know how, this becomes somewhat difficult to explain.